Welcome to today's Energy Central webcast entitled Preparing for NERC CIP 014, Understanding the Regulations and Interpreting Their Impact. A few housekeeping notes we would like to mention. If you cannot get adequate sound from your computer speakers, you may dial into the audio portion using the telephone number listed in the right-hand panel of your interface under the audio section. Following the presentation, we will have a brief question and answer session. Please submit your questions at any time using the chat interface on your screen. Today's speakers are Rick Shumard, Vice President, Utility Services, and Steve Schneider, Chief Solutions Architect, Energy Solutions. To kick off today's event, I'd like to turn the floor over to Rick, the moderator of today's event. Rick, welcome to the event. You have the floor and should have controls.
Thank you very much, PJ. Good morning, ladies and gentlemen, and welcome to the Leidos Engineering webcast on preparing for NERC CIP 014. For those of you who attended our initial webcast on this topic on August 13th, you'll probably notice that some of these slides are quite familiar. We would ask your indulgence as we review some of this information for the new participants who weren't with us in August. Before we get into the heart of the discussion, I'd like to briefly introduce myself and my colleague, Steve Schneider. I'm Vice President for Utility Services at Leidos, and I work primarily with investor-owned utility clients on projects that include grid planning and operations, transmission, substations, distribution systems, intelligent grid, and of course, physical security. Prior to coming to Leidos, I spent more than 28 years with the Electric Power Research Institute in advanced technology sales and applications. My colleague Steve Schneider is our Chief Solutions Architect and Director of Technology Integration for Leidos Engineering. He's responsible for creating new business models that meet complex new business requirements, and a perfect example of that being the NERC CIP physical security regulations. Steve has over 2 decades of investor-owned utility experience. Leidos is entering into this discussion because we feel very confident that we offer a unique perspective on utility security. First, we have decades of experience in critical national security infrastructure, and we've been performing national security activities since our founding in 1969, which include cybersecurity, force protection, and electronic security systems. We have more than 70 years of utility engineering experience going back to our heritage from our acquisitions of R.W. Beck & Associates and Patrick Energy Services. Additionally, we have performed physical security post 9/11 on many airports, seaports, and critical Department of Defense installations. We look at utility security as the convergence of national security into the power and electricity sectors, and our background in this arena gives us a really broad view of the NERC CIP 14 regulations and the potential evolution of these guidelines. This slide shows some of the common questions being asked by utilities as they confront challenges that will result from the new CIP 14 regulations. New threats are out there that are radically different than those that we're used to over the years. We also know that the environment in which utilities operate is constantly changing. Leidos wants to help frame this discussion and help drive the thought process in the right direction. Some of these questions are, how does this impact my utility going forward? What are the best practices that other utilities are experiencing and using as they move towards compliance with CIP 14? How will CIP itself evolve as we have new learnings and as incidents occur? And how can I take advantage of the new regulations? What led us to the need for CIP 14? Well, in a few minutes, Steve's going to show a timeline of events a little bit later, which will show how much of our nation's early and recent approach to critical infrastructure protection stems from the National Infrastructure Protection Plan, which was issued by the Department of Homeland Security. This plan was first released in 2006, revised in 2009, and then again in 2013. The plan outlines how government and private sector participants in the critical infrastructure community can work together to manage risks and achieve security and resilience outcomes. We know that utilities will probably not have all the protection they would like to if money were no object. So we have to consider the following kinds of questions. What types and how many levels of physical protection does a utility need? And just as important as how much is enough, how much is not enough? What can we do to not overinvest in this? How much technology, how much hardening, how many people are needed? What are the financial constraints that we're faced with as an industry and as an individual company? And then how will we know when we've done enough to protect our critical utility assets? We can put money and other resources towards solving our physical security issues and all the while prioritizing what's critical, but we know someone will still try to figure out how to defeat everything we devise as solutions. In 2006, the DOE Energy Sector Specific Plan under the National Infrastructure Protection Plan identified high voltage transformers as a major electric grid vulnerability. These transformers combined with control centers are the focus of CIP 14. Now why is that? Well, taking out a high voltage transformer or substation can cause significant grid stability issues. Because the U.S. grid is a highly interconnected facility, one equipment failure can occasionally have a cascading effect on a significant portion of the grid. Transformers and substations were not initially designed to protect against these attacks. Many high voltage substations exist. This map itself shows over 2,100, 230,000 volt and above transformers in substations. That's an awful lot of targets to protect. Transformer replacement lead times are long, sometimes as much as 60 to 80 weeks, depending on the location of the manufacturer and the size and type of the transformer itself. On-site repair to damaged windings is a difficult proposition at best, and most probably impossible to accomplish in many instances. Transformers are very difficult to move, with significant logistics and planning required, and permitting and planning required to make that happen. This slide shows a simple rendering of what a high voltage substation might look like that's been identified as a critical facility under CIP 14. As I talked about in the last slide, this is a primary target of a person or group with the intent and capability of harming the utility or the greater electric grid. So when we look at security, we need to put ourselves into the mindset of the group trying to damage us and consider what will this malicious person or group focus upon. They're going to be asking themselves, for example, what is the critical equipment I need to target to cause maximum damage? How can I gain access and entry to the facility? Can I damage the supply, the transmission lines, if you will, to the substation? And can I damage the controls so the substation does not work properly? Is it possible for me to hack into the computer systems to gain control of the facilities, provide misinformation and misdirection, confuse or disable components that are essential to the safe operation of the system? In our upcoming webinars, which we'll talk about in a little while, we talk in greater detail about how to mitigate these issues and to prioritize your responses. But initially, thinking like the bad guy is really important to establishing a robust security plan. Now, as a security consultant, we know not to share all of our knowledge in this public forum. We want to share high-level information on approaches and techniques with usefulness as you develop your own plans going forward. The environment in which utilities operate, as I mentioned earlier, is changing and evolving constantly. Recognizing increased threat profiles is a moving target for all of us, but we know that the utilities must optimize how their people, facilities, processes, and technologies can be best mobilized to address the physical security question. And of course, both external and internal threat profiles require utilities to carefully plan and coordinate across the organization and with outside entities such as law enforcement agencies. If you followed the recent history in the last 18 months or so of some of the incidents that have been happening in the United States, we've had a number of them occur. They fall into some fairly definable patterns. One is coordinated risk attack. The Metcalf substation incident of April 2013, and then Metcalf number 2 really showed us just how exposed some stations are out there on the grid. Physical attacks remain an ongoing issue with utilities. There have been other more recent attacks in the news, such as at Entergy, including property theft. Another example is the disturbed individual or insider. In the Entergy incident, the 2013 attack in Arkansas was an attempt to bring down a transmission tower. And then cyber hacking is one that we're all very familiar with. For example, a Russian group of hackers with a campaign named Energetic Bear is attacking energy companies in the United States and Europe and is attempting to disrupt national power grids as much as they can. So with these introductory thoughts, I would like to now turn it over to Steve Schneider, my colleague, and let him take us through some of the CIP requirements, and then he'll be handing it back to me a little later. Steve?
Thanks, Rick. It's always good to know where you've come from when you're trying to help determine where you're going to be going in the future. So we put this timeline together to show over the last 15 years how the many standards, studies, plans, and collaborations in the utility arena and security have really evolved over time. Now, if you take a high-level look at these security requirements and plans, you'll note they've moved from a voluntary suggested stance to a prescriptive mandated approach. And also, the primary focus over this 15 years have changed. Initially, the standards were set to simply address theft, vandalism, and unauthorized access. Around 2005, the focus shifted to a cybersecurity perspective. And then in 2013, right after the Metcalf coordinated attack in the West Coast, the focus instantly shifted back to a physical security perspective. So much like aviation had a huge precipitating event for increased security, 9/11, Metcalf was really the U.S. electrical grid's wake-up call. And so CIP 014 is the NERC FERC response to this wake-up call for the industry. So, we just talked about some of the high-level trends that were driving up to what led to NERC CIP 014. So let's explore what NERC CIP 014 is really all about. As Rick had mentioned, in 2006, the DOE Energy Sector Specific Plan under the National Infrastructure Protection Plan, which is easier said as NIP, identified high voltage transformers as the major electrical grid vulnerability. Now, these transformers combined with control centers are the focus of CIP 014. In reality, CIP 014 is the response to NIP's high-level threats and vulnerability analysis on the electrical grid. As I mentioned, the high voltage and the control center, the high voltage substations. So CIP 014 is about addressing the threats, the vulnerabilities, and the risk of those substations and control center in a structured framework. And that structured framework is really focused around 4 key anchors, if you will, which are protect, detect, deter, and delay. Now, I mentioned CIP is a structured framework, but it's also flexible. It's structured in the sense that there are 6 requirements that apply to a predefined classification of critical elements wrapped around by a couple independent third-party audits and validations. It's flexible in the sense it allows the utilities to craft customized responses as they see best related to their unique service territories and parameters. Now, a second spirit of CIP 014, in addition to that structured framework, really centers around cost recovery. CIP has a structured framework, as I mentioned, with the third-party validation. As such, the utilities can use the FERC-NERC requirements in conjunction with these validated plans as part of their respective rate recovery plans with regards to security. Now, as a side note, I think you're all aware that on around July 16th, FERC directed NERC to include 2 modifications in the original draft document that came out, one of which involved having applicable governmental authorities add or subtract critical facilities from the list that the utilities put together. We believe this modification enables critical facilities that have critical national security functions such as the intelligence community facilities, key DoD military bases, and other critical government facilities to be included so that they would not be inadvertently overlooked. We're not exactly sure of the exact SIP drop date, but we anticipate it will probably occur over the next 30 to 60 days. Okay, so as I mentioned, SIP 014 has 6 requirements, so I'm going to lightly dive into each one of these requirements, give our interpretations, and some suggestions of what you think may be good for the utility to focus on. Now, R1 is really all about determining which substations and control centers are critical. Now, by criticality, SIP basically defines criticality around an electrical grid stability. I guess the formal definition of if a facility is rendered inoperable or severely damaged as a result of a physical attack, and the inoperation of that facility, if it results in widespread instability, uncontrolled separation, or cascading with an interconnection, that's considered to be a critical facility. This critical facility listing in R1 is what your entire SIP 014 plan is going to be based on. So with that said, what are some of the key points you really should be focusing on in this R1? Well, first of all, not all substations in your service territory will fall under the SIP 014 requirements. You should consult the official SIP 014 document for the complete wording and applicability, but a quick rule of thumb is that a substation that's over 500 kV or a substation over 200 kV with 3 downstream substation connections fall under the SIP 014 requirements. The second one that you ought to know and realize is that the critical list will evolve as criteria, threats, vulnerabilities, and risks shift. A key takeaway is that this entire SIP 14 process is an evolving, living process, and as such, each of these requirements should be refreshed periodically. And the third parting thought is not all critical substations are created equally. Factors such as the ease of moving a new transformer into place, spare availability, what critical governmental facilities are served, all those can and should impact your prioritization plans and your resource spends. Now, I mentioned that SIP requires a third-party audit. Requirement 2, or R2, is the third-party audit of the utility's definition of what is a critical list under R1. If deficiencies are uncovered, this third-party validator will work with the utility to fix those issues. Again, as I mentioned before, this third-party validation is actually important because not only does it help you identify your critical facilities accordingly, but it can also help you when interfacing with your local regulators for cost recovery. So with R2, we suggest that you look for a third party that has both transmission planning experience or utility engineering experience and a security background so that you can couple the security and the utility piece together. And we also suggest that you work with your R2 third-party auditor in a very collaborative fashion because being able to get into the thought process and understand the justifications and rationale behind the critical list is very important. R3. So R3 is not applicable to all utilities. It really only applies to utilities that have transmission operations operators that are different than the transmission owner. So for a primary control center that is not under the operational control of the transmission owner, there needs to be a coordination plan put together so that there's a crystal and clear communication and protocol process. Okay, R4, threats, vulnerabilities, and risks. This is where the rubber meets the road. And these assessments will form the basis for your strategic plan and your infrastructure investment requirements from your critical facilities noted under Requirement 1. Getting it right is vital. So at a high level, what are you looking for in this? Who can hurt me? Why do they want to hurt me? Importantly, do they have the capability to hurt me? What are my vulnerabilities? What are my risks? What are my countermeasures? Can I and should I, and what's the best way to deter, detect, and delay? So when you look at all this put together, it's in the basis of forming a risk management identification and plan. And a risk management plan is when you take threats, vulnerabilities, and risk assessments and you put them together. As Rick said earlier, thinking like the bad guy is vitally important toward crafting a good security plan. So your threats and vulnerability plan should leverage national threat and vulnerability assessments and risk frameworks, because much of those frameworks already have how does thinking like the bad guy integrated into it. Several methodologies do exist. There's Carver out of DOD, there's Thyra out of FEMA, there's RAMI, DHS has one. With all that said, your threats and vulnerabilities should be customized for your unique utility. Much like a patient has a customized prescription plan for medicine over a doctor, taking those steps to ensure that you understand the nuances, strengths, weaknesses, and applicabilities of all those different methodologies and how to best tie them together is very important. It's also important to note that threats and vulnerabilities will evolve. A perfect example of this, I flew in a plane 2 days ago, is the TSA in airports. Originally, 911 occurred because there was a box cutter that came on board and they used that to threaten the cockpit. The response was metal detectors. A little later, there was the TSA shoe bomber incident. Now we have to take off our shoes. Now we've evolved to full body scanners that look for liquid gels and other potential threats. So that is a protocol where the countermeasures are responding to the threats and vulnerabilities. As a parting note on the requirement 4, it's important to use quantitative measures as part of your threats and vulnerability and risk, so that you can use that to set up a proper prioritization, which will be used for implementation. So I like using a car analogy. So in keeping with the car analogy, much like requirement 4 was the rubber meeting the road, R5 is the GPS route to achieve the best compliance. So when we take a step back and look at the CIP 014 plan, I view it as similar to a reliability plan for a utility. So a reliability program can have cable replacement, pole renewals, vegetation management, a whole host of splice replacements. You can have a whole host of ways that you can improve safety and safety for your utility. It's a holistic plan. Your security is no different in principle than that reliability plan, in the sense that it's a holistic consolidation of all the security components, the threats, the vulnerabilities, the critical listings, the risk, putting them together all into a composite plan. A plan should have really 4 focuses of area we feel important. One is a people or an operations process. You should be able to have the people train, the operations, the protocols all put together, combined with, number 2, a process. Your plans, your measures, your procedures, your interface with your third-party law enforcement. Obviously, you should have a physical security and a build-out perspective to it with regards to materials, hardenings, appropriate timelines. And there also should be a technology plan there, because there are technologies and they are evolving to be able to implement. For instance, is it better to put a wall up or put a Kevlar shroud around a transformer? There's different ways to approach that, and looking at new evolving technologies is very important to keeping a plan that is very effective. As I mentioned, the plan should use a programmatic measured approach, and you will be prioritizing your resources and timelines against what's appropriate for your security goals. You should tie into resiliency. If you can get multiple benefits out of running your security plan, absolutely should do so. Should drive operational excellence. It should be tied to a realistic time frame that is tempered by your investment capabilities, and obviously should include external first responder and law enforcement interfaces, and really be a tool for operational and response personnel. Simply, much as a catastrophic storm plan is put together, there should also be a good security plan. Above all, realize that this, again, is a living document that is going to be evolved, needed to be reassessed and updated and implemented over time. R6. So much as requirement 2 had a third-party audit with it, FERC and NERC in the 014 plan requires a third-party assessment of your threats and vulnerability and risk assessments and your implementation plan. So similar to requirements for 2, you'll go out and get a third party, and that third party should have transmission experience and a security experience so they can blend the best of both worlds to be able together to work with you in a collaborative fashion to review and, if required, fix any required found deficiencies. Okay, we've gone over the spirit and intent of CIP. We've gone over the 6 requirements. So let's talk a little bit about timeline. So the first thing to note is that there obviously are no dates up here because the timeline has not started because the CIP hasn't dropped and there hasn't been an effective date yet. The timeline starts upon CIP approval. So requirement 1, on or before the effective date from the drop, you'll need to be able to have your critical facility list generated through your methodology. And then 90 days after that's due, the third-party audit will come in and essentially look over that for any deficiencies and or changes that are needed. 7 days after the third-party audit is done, if you happen to be a utility that has a transmission, your owner and your operator are different, within 7 days of R2, you'll need to be able to have the coordination plan put together. Again, from R2 as a start, requirement 4, which is your threats and vulnerabilities, and requirement 5, developing your plan, will be generated concurrently, and within 120 days after that initial third-party audit, they should be completed. R6 then is a 90-day term where your third-party auditor would go in and look at R4 and 5 for your compliance. Now, one of the things that you'll notice in there as I shift into industry activity is that the CIP 014 document did not state you need to be done within a certain amount of time. What you need to do is put together your time frame and a rational plan with your spend plan, and then essentially use that in a coordinated fashion. You do not have to have your entire security retrofits and protocols and improvements done within 120 days. I worked for a utility for about 20 years, and I was always interested in what my peer utilities were doing. How did I benchmark? Was I behind? Was I leading? Did I need to learn more? So I want to take a few minutes talking about what we've seen so far in the utility industry. First of all, as a high level, the FERC NERC 014 is mostly an investor-owned utility issue. Why? Because of the size of the transformers, the 500 kV and above and the 200 kV and above are 3 transformers downstream. But while IOUs are very interested in that, what we've also been finding is that municipals and co-ops are also interested in learning about the broader security perspective. Much like the IOUs and the munis, everyone is really ingesting as much information as they can to learn more and figure out how are the new requirements going to impact me. We've been seeing global questions of how much is the right spend. There's been considerable discussion over, hey, what's spend versus regulatory approval? How do I align with my PUC? What's the best way to do that? So everybody's thinking along those thoughts, and everybody's gathering information. To date, most of the IOUs have not produced official RFPs. But for those that have and the ones that we're working with, the non-RFP activities, we seem to see an even mix between substations and secure control centers. So there's not been a predominant substation focus or control center focus. What we've also seen is most of the initial activity is front-loaded by physical security, but there is a strong recognition that cyber security is very important to the overall security plan. And in fact, in some of the subsequent webinars we're going to be doing, we'll talk quite a bit about cyber and how that ties in. We have seen one IOU that has issued an RFP with a discrete cyber response to it. Of the RFPs predominantly that have come out, we've seen most of them are in a pilot type status in which There's 2 or 3 substations and maybe 1 or 2 control centers involved with it. There are a couple IOUs out there that are doing non-RFP derived pilots and plannings for their existing industry relationships. And again, most of those RFPs are under the flavor of, hey, I know the CIP's coming down. I have some plan put together. How does my plan compare to what needs to be done for CIP? And there are also some utilities that are starting to actively get in front of the public by putting together a press release and public release of information on how they are actually dealing with the CIP 014 and the security piece. So at that point, I'm going to, I went over what the CIP is, what the spirit of intent, what the requirements, the timeline, and what the industry is doing. So with that as a background, I wanted to hand it back over to Rick, who will run through a couple points of how you should start preparing for the new standards coming up. Rick?
Thanks, Steve. I appreciate that. Although we know the utilities will continue to be confronted with new types of challenges, followed by new regulations, quite frankly, it's important to take a flexible long view so that you can position your company to meet both anticipated and unforeseen events. To accomplish this effectively, utilities are developing physical security plans that address threat, vulnerability, and risk assessments. These plans address the people who design and operate and maintain electric grids, the processes employed for developing those plans, measures, and operating procedures, the physical security materials and hardening measures, and integration of appropriate security system technologies and applications. Your long view of the future will start with CIP, but should anticipate that existing regulations will evolve as new needs and requirements are identified. Steve addressed this with his remarks on R1. And finally, your plan should focus on enhancing physical protection, improving deterrence capabilities, and fine-tuning response capabilities for when these kinds of events do occur. Now, a few observations on CIP 14. You should consider using the understanding of total cost of ownership and return on investment to achieve operational excellence while you're balancing the financial requirements of your plans. Every utility is unique, as Steve said. Plans need to be based on a solid but flexible framework, and each utility may require a tailored approach. Most of you already think about your response strategy to natural disasters like hurricanes and tornadoes. And these strategies include mutual aid, law enforcement coordination, and other agency support. Much of that strategy can also address physical security events. By blending storm restoration planning and physical security efforts, you are more efficiently using your security spend while also increasing the potential for rate recovery. You should plan your security hardening efforts so that they don't negatively impact substation operations, maintenance, and outage scheduling, particularly those of you who are transmission owners operating as part of a ISO or an RTO. While the primary intent of the CIP was for grid stability, FERC's desire to add facilities to the critical list is probably intended for overall national security, as Steve mentioned earlier. Not all substations are identified as critical should receive the same resource allocation. In summary, while the regulations may be newly issued, the types of issues have been with us for many years, and response is sort of part and parcel of keeping the lights on and protecting our critical infrastructure. Meeting these new regulations is more than just checking a box on your to-do list, because careful consideration is necessary to ensure the appropriate level of protection. There aren't enough resources that can ensure 100% protection, so planning for deterring threats, mitigating vulnerabilities, and minimizing consequences of an incident are critical to overall success. Using a measured approach to planning and implementing your plans will help in optimizing the resources required for meeting the regulations. Carefully coordinate your plans and investments across your company as needed. Now, before we begin the question and answer part of our session today, I'd first like to thank those of you who were with us during the prequel episode back a month or so ago. and for hanging in here with us. And I'd like to identify the fact that after today we have 3 more sessions, one on threats, vulnerabilities, and risks on October 9th, one on developing the security plan itself on October 23rd, and then after that, the last one is moving beyond the SIP on November the 6th. The episodes 2 and 3 are really the meat of the whole presentation, and on those episodes we will have some of Leidos' top subject matter experts come in and talk about the issues around those areas that the episodes will cover. And lastly, before we open it up to questions and answers, just additional information. Here's the contact information for myself and for Steve Schneider. We're more than happy to talk with you by phone or by email, whatever is most convenient for you. For a copy of today's presentation or to submit a question, and I see some of you have already submitted some questions, there is the website for that. We've also given you a link to the NERC criteria on the NERC website as well. So with that, I believe we will be opening up the questions. Let's see here. We've got a list. I will take a look here. Give me just a second. I'm looking at this list. Okay, the first question is, would it require security clearance to work on utility SIP programs? Steve, how about taking a crack at the answer for that one?
Sure, yeah, the short answer, Rick, is no, it does not require a security plan to work with the SIP response. Now, that said, there are some instances, particularly in the cyber arena or other security-related instances, where there may be a pertinent national threat. So occasionally what will happen is the CIO of the utility or other key components of the utility, along with the security consultant, can be given a temporary security issue or clearance to be able to discuss that. There are also some secure communication protocols that have been set up by the DOE that actually allow the utilities to talk back and forth in a secure environment, not actually having the security clearances. I know, so the short answer to that is no. There are also, I guess, some Executive Presidential Order 13636 and a Presidential Policy Directive 21 or PPD 21, which talks about some security clearances too. So if the questioner wanted to get a little more detailed information about that, Executive Order 13636 and Presidential Policy Directive 21 can provide a little more detail into that security-related question.
Thanks, Steve. The next question we have is one of the participants is asking, would R6 mean the penetration test? Steve, I know you have some thoughts around that as it compares to cybersecurity as well.
Yeah, so the answer is no. R6 is not a penetration test requirement. Penetration testing is typically around a cyber piece, so that's more covered under version 5 when it comes out. R6 is more primarily intended to be an audit of looking at the rationale, the resource spend, the threats and vulnerability analysis, and uncovering if there's any deficiencies associated with the macro thought process. Thanks, Rick.
Steve. You bet. Thanks. The next question is electromagnetic pulses and geomagnetically induced current mitigation are big issues for some utilities. How do EMP and GIC mitigation apply to the physical security plan development? Those are clearly important issues. There is a lot of work going on in the industry amongst a number of different solution providers. EPRI, the Electric Power Research Institute, has also done work in both of those areas, and for those that have issues and are concerned about the effects of solar storms, as an example, on neutral currents in major transformers, you can certainly include that in your plans, and if you are planning on providing protection against such phenomenon like that, we encourage you to do so. For EMP, we have done a lot of work at Leidos and another part in our national security area on protecting against the effects of electromagnetic pulses from dirty bombs or other types of atomic activity. So, Steve, do you have anything to add on that?
No, other than, I guess, an EMP, and you could look at just at a high level as resiliency and EMPs and reliability and security all tie together in the same basic premise of how do I keep my power up and running across my grid. So, they do tie together naturally, as do other concepts of resiliency and storm restoration. It's a macro piece of how do I keep my grid up and running and stable.
Great. Okay. The next question, how do you see the timing for a fully engaged implementation of CIP 14? Steve went over a timeline and some detailed discussion about each step in the timeline. And most of the discussion we're hearing from folks saying that they're looking at being prepared with all their plans probably no later than June of next year. Some are moving much more quickly than that. Some are moving to meet that particular goal. But Steve, do you have any additional thoughts on that?
Well, other than, again, is if you look at fully implemented of when is it finished, that's going to be a unique answer to each utility because of their spend plans, how big is their critical facility base and whatnot from there. The intent of the NERC CIP 014 is not to snap your fingers and have it done and bankrupt the utility. It's to do it in a timely fashion with a well thought out framework to get toward the end goal, and understanding that it will evolve over time. But it's not an instantaneous snap. But I think that a few years out, putting it all together would be acceptable. But again, that's based upon each utility.
Okay, thanks. The next question I see here, how will substations owned and operated by industrial users be addressed by NERC CIP 14? Steve?
Sure. So keep in mind, not all substations are going to, again, in the utility itself, there is over 500 kV or 230 kV or 200 kV and above with some interconnections below it. So although there is the potential that if a government under the requirements indicates that a facility needs to be added, obviously it would be added and included under there. But for the vast majority of C&I customers, they typically wouldn't fall under that. My guidance would be if you do happen to have a 500 kV input into your, your customer substation, I would reach out to my utility and have those discussions with them now. But for the vast majority of the C&I customers, their substations would not apply to it.
Okay. I think the other questions I see have been answered by what we have done so far. Let me see if I'm missing anything.
Hey, Rick, while you're looking, this is Steve. I just wanted to go back to that penetration testing with cyber.
Sure.
It's combining cyber and physical security is important to have a truly holistic total plan. And I just want to, in our next webinar coming up, we're going to have one of the leading cyber technologists talk about threats and vulnerabilities associated with cyber. So if you wanted to learn a little bit more about the cyber version 5 play and how it integrates into the CIP 014, that next webinar will Gip Sorbo from our Chief Technologist in Cyber is going to talk a fair amount about cyber.
That's great, Steve. Thanks for that. Steve, I think there is maybe one last question, unless some others come in here at the very end. You've mentioned resiliency during your discussion. How do you define resiliency, and how do you see resiliency as it relates to physical security?
Well, that's a good question. It's actually a thesis question, but I'll try and answer it nicely. As I mentioned before, resiliency is all about how can I keep the power up to my grid and keep it so that if there's a component that is damaged, that it essentially is resilient enough to continue to deliver power. So security is essentially the same thing of how can I minimize and address my critical facility so I don't cause a cascading failure across my, my high voltage grid. So the two closely interrelate together. So there are issues that you can do with substation design that address both resiliency and also address security from that point. So there's a very close overlay to that, which goes back to what I was talking about before. When you're developing these plans, it's good to have a security perspective and a utility operating engineering perspective together so you can get an overlapping synergy. For instance, one thing you would not want to do is put a wall up around a transformer that would inhibit you to be able to operate or maintain or take an outage on your high voltage system. So those two tied together, the fundamentals of keeping your power up and running are across the board for reliability, resiliency, and security. The art of it is putting together how can I get 1 + 1 = 3 out of when you deal with security and resiliency.
Thanks, Steve. We've got one more question queued up. While I'm reading the question and answering, if there are any of you out there that have just been dying to ask something, go ahead and get it in under the deadline and we'll attempt to answer it. But this question is, how are the Canadian developers and utilities affected? Do they, particularly if they plan to export to the U.S.? Well, I suppose the simple answer to that is that the NERC and FERC really are intended for U.S. utilities as far as how they who they regulate and how they regulate them. But I can say this: I was attending a North American utility meeting event where this topic was discussed in Vancouver, British Columbia, a week before last, and that topic did come up. The BC Hydro representative, without going into too much detail, he basically said that the Canadian utilities are carefully looking across the border between the U.S. and Canada and looking at what we're doing in this area, and they're going to pick best practices out of that. They feel like they have already been doing some of this to date, but they realize that there are some gaps and they need to address those. Steve, do you have any additional thoughts on that?
No, again, I agree with you. It's primarily a U.S. NERC or I guess a FERC issue from there, but that's, you pretty much hit it on the head.
Okay. I think that is probably, unless someone wants to rush one in, we're going to bring this part of the discussion to a close. PJ, I'll hand it back to you.
Thanks, Rick, and thanks, Steve. Fantastic presentation. For our audience, we hope you've enjoyed today's discussion. As you log off, please take a moment to complete our survey and give us your feedback so we can continue to provide you with quality content. Thank you for attending, and this does conclude today's presentation.